well. When we start to make a casting for the foundry, it has to start in engineering. The engineering makes a model of the part we want to make. Then we move it to electronically file a model of it, 3D model, gets moved to our process engineer here, and he will work on it and work on laying out the runner system and the gating and everything else that we need to get the metal to the casting. And he'll also, we run it through a solidification program that helps us show how the metal will cool after we pour the metal in. The metal will shrink as it cools. And so therefore we have to add material to the pattern, make it slightly larger to make the casting come out the shape we want in the end. So we have to allow for that shrinkage of metal. And the solidification program is utilized to reduce our testing that we may have to do on the floor. We can get it right the first time, or at least the second time. We got a better chance of that. We'll walk over here and we'll show you what we start with when we make a pattern. Over here is a pattern. You can see inside the machine here, there's a CNC machine, a block of red board. It's a sort of a plastic that's made specific for making patterns. It has good wear characteristics, good dimensional stability to make the pattern for making parts in the future. You see the parting and the CNC machining that's done here. You can come take a look just over here a little bit, and you can see that how they convert the models to the CNC program. They got a program that converts our 3D model to CNC machining code. And the next step in the pattern making process, they'll make a runner. This is the runner, is the material to get the metal to the casting. We got a gate, which is the contact area between the runner and the casting. And this is the actual part, or what will be the casting. It gets mounted on a board, and then we mount pins on the board that are, because we make the mold in two halves. This happens to be the drag half of that mold or casting. The drag meaning the bottom. There's a filter in here. The metal comes in and goes down this way. We also have the pins here that hold us for the registration from one half to the other half mold. We use bushings that are embedded in the sand when we make the mold, and then we put pins in those bushings, and then we use that to align it, so we got alignment when we make the casting. The Foundry process, our main molding line is with green sand molding, and this is the sand we use for molding. It's silica sand, which comes in very much like this, white silica sand like you'd see on the beach almost. And then we will coat it with clay, and that's where it gets the black color. The clay coating gets burned onto each individual sand grain. And we mix it with water to bond the sand together so we can make an impression in the mold, and in that impression we'll pour the casting. We do sand testing every batch of sand. We test the sand in the return sand bin. We test it for moisture and temperature, and then we drop that sand into the mixer. The mixer will mix the sand, and it'll add the 4,500 pounds of sand with the clay and new sand replacement. It'll drop into the mixer, we'll mix it, add water to get to our set point, and then when it's discharged into a return sand bin, and as it's discharged, it's checking the sand to see what the compactability and moisture and clay content is of that sand electronically. Along with that, we pull a sand sample like this from the molding line right at the molding machine, and we do additional tests. We'll do several additional tests, 10, 12 different tests. Grain fineness, LOI, which is combustibles type thing, loss on ignition. We do permeability, the ability to get gas out of a mold. And when we pour sand, metal into the mold, and we got the cores, we got to get the gases out. So we got to have the mold permeable to release the gases. Along with that, then we also have our metal lab up here. The metal lab, we'll send the plug up to the lab before we pour any metal out of any furnace. That plug will be sent up to the lab here. The lab technician will do an analysis of the chemistry in this product by a light spectrometer analysis, and he gets a printout of this, and it'll automatically compare it with the spec that the metal is, and if anything is out of spec, it'll show up for red for the operator to know what's out of spec. But typically the metal is in spec. We sometimes have to make adjustments for zinc, because zinc tends to fade. So once that metal is approved and everything's in spec, he puts a note on the sign up to the metal lab, to the melt floor, to get it, to tell them that it's okay to transfer the metal and we can pour it into a casting. When we pour it into a casting, we also periodically will pour test bars, and the plug will be on that test bar also. And so we got a chemical and a mechanical that matches together. We'll do the chemistry on that also. We'll go and put a bar and a pencil bar tester here, pull the bar apart, and we get a yield strength, we get an ultimate tensile strength, and then we get an elongation. These points, we measure these points. They start out at 2 inches. There's a minimum elongation, there's a minimal yield, and a minimal tensile that we have to meet. And then that record is also inputted into a form like this, and kept again electronically in our system for each set of test bars that we do. We also have a no-bake molding line, which I'll be showing you later. That's a molding line that has a sand, it's again silica sand. It's mixed with 2 resins, and then we have a catalyst that activates it and hardens it. It'll harden it into a very hard piece for molding. This here happens to be what we call a dog bone. We make these dog bones regularly during the day, and we'll pull them at 1 hour, we pull it at 4 hours, and we pull it at 24 hours. And we monitor that tensile strength on those molds, because it's critical on how that is. We also do an analysis of the grain fineness for the new incoming sand, for the reclaimed sand, and then we mix new sand and reclaimed sand together, and we do an analysis of that also. All of these get an LOI and a grain fineness. The grain fineness is very critical on both the green sand system and the no-bake system, because if we get it too fine, we don't get rid of the gases like I talked about earlier. If we get it too coarse, we get a very rough casting, a poor finish on our castings. So we got a very critical balance that we have to have on the grain fineness. Okay, this is a little description of our sand system here. We have a sand silo that contains about 105 tons of sand. Our mixer mixes sand at the rate of about 67 tons an hour. It's about 4,500 pounds of sand every 2 minutes and 10 seconds. And here's our additives. We'll put our additives in, new sand and clay will get added into the 4,500 pound batch. We pre-weigh that before it goes into the mixer. It drops into the mixer, does the mixing, and goes out to the machine and gets distributed to the machine, to the molding line, as it's called for automatic demand. There's probes on it. If I draw a line through here, this would be our base floor. We got spill sand conveyors and shakeouts below floor, and the shakeouts are in the dirtiest, noisiest part of a foundry, which we separated. We don't have, nobody has to work in that area on a regular basis. The castings and runners and screws and everything comes out in the basement. The sand meanwhile goes back up this conveyor, goes into a bucket elevator, and we screen out any core butts and fine metallics after that. Any conveyor that shuts down will shut down the whole system that feeds it and behind it, and it'll shut down our molding line so we don't bury anything in the sand. We have 0 speed controls on all of it. Okay, this is our main freesand molding line. The sand is delivered to the hopper. The flaps are indexed up with the pattern. We drop the sand onto the pattern, into the flap. The head moves back. We flap up under high pressure. And we impact. That impact takes place at about 55 psi. It drops to 43 psi in a few hundredths of a second. It compresses the sand against the pattern to form the cavity in the mold. And then the further it gets from the parting line, the less dense it is, and allows the gases to get out of that mold when we pour the metal. When we go over here, you'll see the mold after we have impact with the mold. It comes out face down, is the post. We have pins and bushings that do the alignment from one half to the other half, so we got good alignment of the casting. Out at the end, we'll show that later, we put the two halves together. This is our melt floor. We have 4 furnaces on our main melt floor. 2 of them are 3,000 pounds, 500 kilowatts. 2 of them are 4,000 pounds, 750 kilowatts. These are cordless induction furnaces. We melt our bronze in. We checked, again, like I talked about earlier, we checked, we pull a plug before we pour any metal, and then when the metal is good, the lab will let them know that it's good. We now transfer the metal to our pouring device, which has a stopper rod, and it holds about 1,500 pounds of metal. With an operator on the looking in, he's monitoring that. It's automatically the data, how much pour time is supposed to be, is transferred to that, and he knows what casting is there, and he matches the pour time with the opening of the orifice to get the desired pour time. We record the pour time, we record the temperature as each mold is poured at. So we have to keep that data also. As he's monitoring, we bring the metal over, and we don't shut down to fill the auto pour with metal. So when the metal is poured in back in the auto pour, he has to close down that orifice opening a little bit at a time because we got hydrostatic pressure increasing. As he has to open it up as the metal goes down to match that time each time. I will go over and we'll take a little overview of the no-bag area. The no-bag area out here, we have some additional melting furnaces. We have 3,000-pound furnaces and 300-pound furnaces. They're dedicated to the different alloys before. We have a furnace that's a group of alloys. We have a furnace dedicated for the Monel, and we have a furnace dedicated for the bronze, and a furnace dedicated for aluminum bronze, and one dedicated for the copper nickel alloy. It's cracked up the mold, it's ready to pour, and the mold with the weights on, you see down there, have the test bars. That's where the test bar molds are poured for this molding line. We have the ability to melt about 10,000 pounds of bronze an hour. Over here, you get started an overview. You get an overview of our molding line. A molding line in the center far corner comes out of the rollover, goes into an oven for curing. On the surface, it goes to our molding line where we'll do the inspection. They'll coat the mold, dry it off with a torch, and then they'll cut the cord and close the mold and put them into our staging area. We have 2 different core processes of the foundry here for the green sand line. The first process I'm going to talk about is the shell process. We get bulk sand already with resin, silica sand with resin coated onto it. We deliver it by surface air and gravity to a blowing vessel. That blowing vessel will clamp up the core box. It will blow the sand into the bottom and hold it clamped up under pressure. We heat it to about 550 degrees for X amount of time. We drop that platinum away, and the excess sand drops out. Therefore, we get what we call a shell core. This core is hollow on the inside. That excess sand that we dropped out, we can reuse and make it into a core. These cores are all one-time use items. This happens to be a core for a gate body. I want to go down to the IceCure setup. This would be an IceCure core that we have. We again buy bulk sand that's delivered to the machine. We automatically will feed it to a mixer. That mixer will put the amount of resin and mix it in on a continuous basis. They can call for different resin content at each machine. And we'll give that resin content and mix it with 2 resin, and then we blow it into a box. Clamped up, and then we bring a gassing head over and gas it with a lean gas. And that hardens the core very quickly, and then we add additional air to purge that gas throughout the core. And it discharges for the he'll inspect it and trim off any parting line indications or anything, and inspect it at the trim. Okay, this is our mowing line. The cores, as I talked about earlier, the cores are set to the automatic mow, which is a drag. This sand is very hard and have a mold hardness of about 92 to 94. They have a round opening and a round pin that makes the alignment. When we put these two halves together, the round pin goes there, and then we got a square pin that fits in elongated holes to allow for expansion as the pattern and the sand heats up during the day and the flat, there's a little bit of expansion, so we got to allow that for an inline expansion. Okay, this area here was where the two halves of the mold pit was put together. The mold half is picked up and transferred to an intermediate area. Drag will be picked up here shortly and transferred over to our pallet that just comes up the sand. There's pins on that pallet. We'll set that drag onto the pallet, engage it in the sand. The line will index. When the line is indexed, the whole half will be engaged into the drag. The bottom half will flow the drag. Meanwhile, the pouring is being done. We have screws on each of these molds, and so we're typically pouring two different castings at all times. One will get poured at one time, another one will get poured like 3.2, the other one 4.1 seconds. And it shuttles back and forth automatically, correctly, putting the right time on each side. So we can make multiple pattern changes. So we run a lot of job shop quantities on a very high production speed. That's what gives us that ability to do that. This here is the screen that we have that sort of shows these are the empty plants coming in. When they're indexed, they come in, once the mold is made, they change color to blue and yellow. You'll see that in a moment here. Right now they're clear. The impact head is coming, the sand is being dropped in. The impact head will go back. When it impacts, they'll change color. Right there. Then they go down the way here, and they go to the closing area, which we just showed you. And put the two halves together. When they're put together, they turn green. When they're poured, they turn orange. And at that same time, we record the time that it was poured, the time that it took to pour it, and the temperature. And then we record, it goes down here, they get punched out, and they go on a screwing belt. And then when they drop into the basin here, we record what time that was also. So all those different information is recorded on a continuous basis. When they're putting a job on, they'll go to the schedule, stretch it, and they'll bring up the jobs that they'll be putting on. They'll highlight the job they're going to do, put it on offline. When it rotates in, that information automatically gets recorded and then transferred to the pouring device. This there is our no bake pour. It's silica sand. It's all blue sand. And you can pour over there. You just put the sand in this mixture. It's resin, 2 parts resin and a catalyst that activates the sand. And he's got about a minute of working time to get that before strip, they come over to an oven for the surface to get, they go into an oven, they go to 2 stages in the oven, they heat up the surface of that mold and sort of burn off some of the resins and gases that are there yet. So the molds after they're poured, they're put in a cooling tunnel. This cooling tunnel, they're allowed to cool. Some molds may take an hour or hour and a half, and other molds may take 6 to 8 hours to cool. He's going to bring the mold, Manuel will bring the mold over to the line, and then bring it to the dump area and dump the mold into a pan feeder, and it'll break open, and he'll pull out the casting. Transferring it to the mold dump line to roll it into the mold dump. The rest of the metal weight has to be remelted, so we're constantly remelting the metal. Troy Pickard again, Foundry Manager from Milwaukee Valve. I'd like to thank you for coming on the tour. This is a brief tour of our foundry and